name is Jonathan Brown, and I'm one of the owners here at B&M Builders. I'm here today with one of my partners.
Hi, I'm David Clark.
We're here today to talk to you about the steps to reopen your business to keep them safe in regards to air quality. A lot's been going on lately with COVID and everything else, and it's come very clear to us in the industry and really to everybody else that air quality is very important. Our team has put together a lot of information to help you keep your building safe. Safe for your employees, for your customers, for anybody who might be coming into your building or bringing contaminants into your building. We've found that listening to ASHRAE, who's actually the world leader in technology for air quality and energy efficiency, that if we follow their steps, we can safely reopen businesses. Okay, so I'd like to introduce you to Doug Sterling. He actually runs our service department, and I'd like to ask him a couple questions about where all these standards come from. Doug, can you explain to us what ASHRAE is?
Sure. ASHRAE is the American Society of Heating and Refrigeration Engineers. ASHRAE is the one that sets the tone for the building energy standards, air quality standards globally. We adhere to them strictly in the United States, and here in California, Title 24 actually follows the ASHRAE standards, along with CDC, and they're the ones that set it all up and make it all happen for all of us every day.
Very nice. So ASHRAE designs Title 24, and then they create the standards to help us go back to work safely?
Yes.
So how often are they changing these standards?
A lot recently with the recent pandemic with COVID and whatnot. These standards change all the time. They've got air quality issues that are coming up, and they're finding with the CDC and the different entities that are helping develop these standards, they're finding that different levels in our internal environment is what's keeping us safe in buildings, and it worked.
Very nice.
And getting us back to work too.
So it's actually ASHRAE standards we're going to talk to you about today, and these are the steps we're going to take to help keep the air quality in your building safe. Let's talk about UVC. ASHRAE has determined that UVC is actually an efficient way to kill COVID and other viruses like influenza. Now ASHRAE you've probably never heard of, but some other groups besides ASHRAE who you might have heard of have actually endorsed this product also. The CDC and the EPA and the FDA all say that this product will kill UVC and influenza. And when we introduce it into your system, your HVAC system that is, either in the ductwork or the air handler, it will be effective in killing all viruses that move through that system. So UVC uses a technology that's been around for only about 4.5 billion years. The sun actually created UVC, and it actually does not reach our environment. There's three types. There's UVA, UVB, and UVC. So UVC actually does not exist in our environment, but the UVA and the UVB do reach down to touch Earth's surfaces. That's where we get our sunburns from and our wrinkling and aging of the skin. UVC actually does not reach our surface at all. So all varieties of UVC in our world, in our environment, are actually artificially created. So what UVC does is it actually disrupts the cell wall. It makes it so that the cells can no longer replicate. And for diseases, this is a big deal. If it cannot replicate, it cannot spread. So what UVC is, it disrupts the cell wall, stops it from replicating, and then makes it so that it cannot spread to anybody else. So to be clear, UVC kills viruses like COVID and influenza. One of the most important steps in keeping the air clean in your building is ventilation. Ventilation is the process of moving air in and out of the building, and we do this in many ways. This is what your HVAC system is actually built for. Actually, ventilation is the V in HVAC. So the main points that we really care about with ventilation is, one, that you're getting 4 air changes an hour. So air change is an industry term that's used for how many times the air moves in and out of your building, basically flushing the air out of a room. So 4 times an hour is actually an industry standard. Might sound like a lot, but it's actually the minimum. Actually, I would actually prefer that you have more of these in an hour than just the basic 4. The next one is going to be outside air. So air coming from the outside of the building and being supplemented into the air that you're pulling from the building. The minimum requirement for this is 35% outside air. So not all units have this because it's a newer standard that needs to be 35% outside air. So this is something that you need to make sure you're checking with your service tech to make sure you're getting 35% outside air. So there's 2 more steps that kind of go hand in hand. One of these steps is that your system is running 100% of the time that it's occupied, which means that your unit is running to make sure air is circulating at all times. If your unit's not running, then everything else that happens in your building doesn't matter because there's no air movement. The next step that goes hand in hand with that is going to be pre and post occupancy flushes, which means that an hour before people arrive and an hour after everyone leaves, you continue to run that unit so that you're getting your minimum of 4 air changes an hour with 35% outside air, so that it basically cleanses the space before people come back in. And really the final step here is the most important, which is that your thermostat is programmed properly. If your thermostat is programmed, it will run this hour before all the way through in the hour after and make sure that everything is running correctly. Step 3 is air balanced, is that you want to make sure the air is balanced in the building. Now what this means that we have all this air being moved and brought in from outside and then programmed to flush and circulate. We need to be aware if the air is balanced. So this is proper amounts of air being distributed through each vent in your building. Now we have a slide up here. As you can see on this slide that we have a 1-ton unit, which can provide 400 CFMs per minute of air. CFMs is cubic feet per minute, and this is a standard of 400 cubic feet per minute per 1-ton unit. So this 400 CFMs is feeding our hypothetical building we have here. So we have 4 registers that will feed 1 for each room. To balance the system, we need proper CFMs from each vent. You can see we've calculated here at 100. So vent number 1, which is the farthest, and vent number 4 is the closest, are going to have different amounts of air coming out. Vent 1 is going to be stronger or weaker, and vent 4 is going to be stronger. So above these vents, you can see these little lines that we've labeled as a damper. So what a damper does is it reduces the amount of air going to that vent. So we're going to use this damper above vent 4, and we're going to decrease the air till we get our recommended 100 CFMs. We're then going to go to vent 3. We're going to reduce that to the 100 CFMs, and then so forth down the line till we get proper CFMs from each vent. We're then going to go back and make sure that these are all where we want them to be as a final check to make sure that our system is balanced. Now, when your buildings were built and the HVAC system was installed, all of these factors should have been set up properly. The inspectors are going to check this. They're going to make sure it was done. However, over time, things change. Services are done, or a different technician comes in and works in the system. They don't always stay the same, especially when Toby from HR, I think we all recognize him, complains that it's too cold in his office. So the quick fix for your tech to do is come in and just adjust the damper above Toby's desk without addressing how it affects the rest of the vents on the line. This is adversely going to affect the rest of the vents by increasing the power and then in return, put stress on the unit. That's that key word again we want to watch out for. So another common oversight is if a new unit gets installed, the system needs to be calibrated to work with that unit. This is overlooked more times than you can imagine. So some quick tips to look for lay people who don't really know how these systems work is that if you have rooms in your building that are commonly the hot or cold rooms, like our conference room is always hot or this person's room is always cold, this is a great sign that something might be unbalanced. Also, if you're hearing noise in the vents, like mass amounts of air coming through, or you're hearing rattling or noises, this is another sign that the system might not be balanced, and a balanced system is a must.
So I want to talk a little bit about humidity in a building. Humidity in a building is one of my favorite things, but actually my favorite thing is Hawaii is my favorite humidity. In a building, it really doesn't come up all that often, and especially in California, you don't really think about humidity much. If you lived in the Carolinas or Texas, you might deal with humidity a little more often. But ASHRAE standard now is 40 to 60% in a building for humidity. What happens is that 40 to 60% humidity, it makes COVID heavy, it encapsulates the virus, it helps get it into the airstream and in that balance building, and helps move it through the airstream out of the lobby and into the filtration system, or if we have a UVC light system installed, it'll go right into that UVC light system and annihilate that virus. That's the most important thing there is we want to annihilate this virus and get it out of the building. If we don't have the proper humidity and it's too light in the building, then what will happen is that virus will float there, and it could get attracted into somebody's clothes. It could go back out the door. It could be carried out or carried home on a backpack or something. And we want to make sure that virus is trapped with that humidity. Given that greater volume and given that greater weight, get it into the filter. So the other thing I want to talk about next is filters. We've kind of covered humidity. ASHRAE standard is 40 to 60%, and we want to make sure we get there. If you're not there, there's different things we can do. Humidification and humidifiers. If it's too high, we can dehumidify as well to make sure that we get into those standards. So now filtration. ASHRAE's filtration, their new guideline is called a MERV 13 filter. And that's the minimum efficiency rating value for filters. On that filtration guide, there's a slide, I think it'll come up here, and it'll show the different levels of filtration and what those filters will catch. Now, MERV 13 is the one that we need to be able to trap those particulates with the viruses and the other airborne pathogens. Of course, it's going to be greater if we can catch it by killing it and annihilating it and then getting that carcass out of your building. But so MERV 13, we want to be at MERV 13. Every building can't operate at MERV 13. That's ultimately where you want to be. Some of the older systems may have a little bit of fatigue with them, so be sure you speak with your service provider, HVAC professional, and be sure that you get to the point where you can comfortably install that MERV 13. That's what you want to have. That's where you want to be. And you also want to get that humidity under control as well so that MERV 13 works really good for you. Like I say, sometimes you may have to take a look at that. And when you put a MERV 13 filter in there, if you have a belt drive system, I don't want to get all kind of technical, but if you do have a belt drive system, you can increase your airflow and move that air through your building and get it good and get these pathogens out of here.
Step 6 this is called an advanced collector system. This is an advanced system that can collect contaminants in the air and neutralize them at that point and then bring them back to their own filter before they reach your MERV 13 filter. This is already in use in hospitals and COVID wings across the country and even in Sacramento. But this is in addition to ASHRAE's steps to open. At B&M Builders, we've really put an emphasis onto education and bringing value to our customers. Keeping the air clean in your building is a must. A lot of people aren't focused on this. It's not most people's priority, but here we are. It's what makes us the clean air experts. We want the air in your building, and really every building, to be clean so that the people inside of it are safer. If we can spend a little bit of time and educate you on what we've learned over the past year on how to make your building safer, we feel like it's only going to be better for you. A lot of service techs don't focus on air quality. I'm just going to be honest, they don't. It's our main concern. We think that focusing on air quality is going to make the system run better, more energy efficient, and it's going to extend the life of all of your units. And for us, this is really what matters. Your HVAC system is the most expensive system in your building. It requires the most maintenance, the most work, and you will spend the most money on it. 75% of maintenance costs on a building end up being for the HVAC system over the life of your building. We want to extend the life. We want to make it run more efficiently so it's not being worn down on by silly little changes and mistakes that can make the system not run at its most efficient rate. We also think that air quality can be done at the same time. You don't have to choose between energy efficiency and clean air. So what we'd like to offer is to give you an air quality assessment on your building, to come in and check the air quality by looking at all of these points that we've talked about today. We'll look at the ventilation, we'll look at your humidity, make sure your air is balanced, make sure you have the correct filtration, and see if UVC light is going to be the right fit for you. We'll come in and give you a grade on your building and tell you what your building looks like and what areas you can improve on to make the air quality cleaner. This should be a priority for you. It is a priority for us.